So this is the setup diagram for the SLS process. So in this diagram one can see that this is the powder delivery system. So this is the, in this system, the whatever the powder material we have used, so those will be stored here, and how much quantity of the powder is required in each layer, so that much quantity of the powder will be coming out, and this roller will take away those quantity from this delivery system to the next where the printing will be or fabrication of the part will be taking. So once a new layer will be sprayed, after that this laser will scan the area where the printing is required. So on those selected area only the heating will be taking place and fusion will be taking place. So this once this one layer of the part printing is done, after that one can go for the next repetition of the task will be done. So here one can use the like a thermal processes, so heat energy is required. Similarly the powder material can be used, so polymer powder material can be used in this process. Similarly the, so here commercialized powder can be also used. So these are the one of the first method which is used for the making of the any product using the powdered bed system. Similarly it is one of the more thermal resources and inducing the powder between the particle is required. So it is the method for the controlling powder fusion to a prescribed region for the each layer. So the mechanism of the adding a smooth layer powder is required in this process. So what are the major component of this SLS process? As we know that we require the energy. So energy, how we can energy for the heating and fusion of the particle is required. So for that we are using the laser system. So this is the laser system which can be used. So this is the laser system which can be used for the production of the laser light, and this laser light will is coming to the scanning system. In that scanning system the direction of the laser light will be changed or maybe focused, so as per the requirement only. So we require the power source. Similarly we require the powder, so for making of the like component, so powder material can be used, a different type of the powder material. Similarly scanning system, so this is the scanning system which can be used for the scanning purpose. So sometimes slow scanning is required, sometimes higher scanning is may be required. So similarly sometimes we require certain kind of the like energy, so those parameter can be controlled. Similarly we require, this is the powder delivery system. So this as we have discussed about. Similarly the powder here fabrication piston. So these are the things we have. Similarly rollers and fabrication pistons. This is the fabrication pistons. So similarly functionally powder, this fabrication system itself will act as the powder bed. So these things, these are the different component of the like SLS process. So how SLS process is working, so those things I have some small videos, so that video
Digital instructions are programmed. The laser unit directs a high-powered beam to a reflective mirror. From there, a galvomotor system steers the focused beam to the powder surface. Each layer of part geometry is then sintered into a heated bed of nylon. Pistons move the supply container up and the build chamber down, while a roller moves across the bed to distribute the next layer of powder. Excess powder is captured in a collection container. The process is repeated layer by layer until the build is complete.
So in this way we can see that here how the printing is taking place in the SLS process. So those small video one can understand. So coming to the here, the first thing you have to perform a dispersion of the powder material on the build platform or powder bed system itself. And then sometimes we require preheating the powder, because sometimes powder will be not having in such a condition, so suddenly it can take the like sometimes it may having the some foreign particle content, so those particle will be burned out during the preheat treatment. Similarly, sometimes maybe some of the powder will be having some moisture contents, so those moisture contents has to be removed out, so that while actual printing will be taking that time, whatever the heat energy is supplied, so it will be uniformly distributed to each powder particle. So each powder will start the partial melting and the fusion will be taking place for the all those particles. Similarly, the scanning of the entire area of cross section is required. So for that, laser scanner will be there. So laser scanner will move away the this scanning system, so that what are the area in which our CAD model is designed, those area only it will scan. So similarly, it can be used for the once scanning is taking place, so that whatever the heat energy of the laser system will be there, those heat energy will be supplied to the powder or transferred to the powder. So powder will be heated and then fusion will be melting, partial melting will be starting. So because of the partial melting, and then some of the surface material will be in molten state, so that time fusion of the one powder material with the adjacent powder material will be taking place. So similarly, the followed by the loading of the, you have to, once one part is one layer is built, that time again you have to reduce the your build platform down by one layer thickness. So that's why new place of the powder will be spread on the already built layers. So similarly, this process will be repeated unless last layer will be printed out. So this kind of things one can follow. So this is the experimental setup which consists of the 400 watt fiber laser. So you can say that a different design of this customized setup. In that customized setup, so this is the a shielding chamber. In that environmental oxidation has to be stopped for that purpose. So here the this chamber is shielded with the some, and then this is the perspex body. So in this body itself different arrangement are done. So this is the laser head, similarly the quartz window, this is the quartz window. From that window laser is passing. Similarly, this is the laser beam, and this is the piston, where this piston cylinder arrangement is there. So here the micrometer head, and this is the base plate. So similarly, the laser head is mounted on the CNC jet stage that can move up and down for getting the desired beam diameter. So this can be this can be moved up and down, so that what is the desired beam diameter at this printing area, so those can be decided here in this. So similarly, it may have the sintering chamber with the different purging gases. So in that, different purging gases will be required, so that during the fabrication, so no environmental oxidation and other things may be possible. So those things we have to ensure it. So this is one of the other diagram in that. So this is the beam delivery system, in which this is the laser source. From that laser source, the whatever the laser will be there, beam will be there, those beam will be produced during the optical fiber. So this is the optical fiber in which multiple internal reflections of the whatever the laser source light is produced. So after that, it may streamline to the single source of the light. As we know that laser light is monotonic in nature, so this will be made from the single source of light. So similarly, this is the beam expander, so that whatever the beam is produced, that beam is expanded to the desired area. So similarly, the collimated beam will be there. So whatever the beam will be there, so those will be combined together. So in this collimation process will be taking place. So similarly, the optical lens are used here for the concentrate that beam of the light to the single point. As we have seen that this is the conical profile. Why conical profile? And this is the straight line or cylindrical type of the beam will be there. So those beam having the more area. So but we, and here we require very less area where the more heat energy should be supplied. So for that purpose, this beam will be focused to the certain focal point only, and their highest energy will be there. So that's why this is the focal point, and this is the Gaussian profile. So as we require Gaussian profile, so that maximum energy will be coming at the certain focal point. So in coming to the what could be the scanning profile, so those scanning profile I presented here. This is the laser beam. So this beam will be moving in this direction. So first layer is scanned, after that this will come this way, then it will scan like this, and then it will come like this, and then this will scan like this, and this will be repeated as per this path only. So this path we have to follow. So what will happen? This entire surface area will be scanning will be done, and then entire area will be printed. So after once this area or desired area is scanned, after that one can go for the next layer of the printing. So here this is the layer thickness from here to here. This is the one layer thickness, and this is the hatching gap. Hatching gap is nothing but the distance between the two adjacent path, so that one can know that how what could be the next layer difference between the path of the two different path. So there are different process parameters that need to be controlled, so that whatever the customization is required or energy beam is required, how much energy is required, so those can be controlled. So those includes like energy beam. So whatever the energy of the laser beam will be there, so those beams, similarly effective diameter of the beam, similarly the spot size of the beam, scanning speed, so beam mode, similarly continuous or discontinuous mode will be there. So these are the very important process parameters related to laser beam. So similarly the other parameters maybe include powder materials parameter, what is the average size of the particles. As we know that all particle will be not having the same size, uniform size. So some variation in the powder particle size, similarly shape is also maybe possible. So that's why geometrical shape of the powder, similarly reflectivity, absorbivity and transmittivity. As we know that in laser it is the light source, so sometimes the light energy will be reflected by the some different materials. So different material may behave differently as per their these properties. So what is the reflectivity, what is absorbivity, similarly transmittivity. So those one has to be knowing about, then no one can decide about what kind of the laser energy is, how much energy is supplied. So this can be decided. Similarly the reactivity, ambience gases will be there. So those parameter one has to know. Similarly the geometrical parameter, what is this hatching distance, so adjacent distance between the two scanning path will be there, so that we are calling in the hatching distance. Similarly hatching pattern may be rectangle, linear profile, or maybe zigzag path, or it may be other profile. So those profile I will be discussing in the next slide also. So similarly the hatching pattern, similarly what is the powder layer thickness. Similarly, we have discussed in the earlier slide that what is the purging parameters will be there. Purging parameters nothing but the what is the gas related parameters. Na? So those parameters what is the oxidizing properties of those selected gases will be there. So similarly what is the reducing, then whether it is the reactive, non-reactive or inert, those can be decided. And then what is the quantity of the gases which is supplied for the purging purpose. And now coming to the calculation of the energy or power density of the given laser beam. So this is the one profile. In that profile you can see that different area will be mentioned here. So this is the here beam diameter. So from that you can see that from this distance to this distance is called as the standoff distance. Similarly from here to here, this we are calling the standoff distance, which is 92 meter. Similarly from here to here is called as the focal distance, which is 80 meter. So similarly this is the focal point where the maximum power intensity will be there. So generally for this operation we are taking at the focal point, so that at the focal point maximum energy density will be there. So these are the different parameters. Similarly depth of the focus will be there from here to here. So in this area, so almost a similar kind of the energy will be there. So those area can be focused during the process. Similarly from this formula one can calculate the power density, which is nothing but the beam power by the spot area. So we have to find out the spot area. For the spot area one can calculate the spot diameter. So once you know about the diameter of what is the spot area, so those diameter spot area can be calculated. So diameter of the spot area can be calculated using this formula. So in that formula you can see that only this frequency and then wavelength of the what is the beam energy there. So those parameters there. Similarly the beam quality factor is also there, and D is the beam diameter at the lens. So this is the beam diameter at the lens, and this is the diameter of the spot area. So this is the spot. So at this point what is the beam diameter, so that from that once we know about this diameter, then we can calculate the what is the area. So once we know the area, then we can calculate the what is the power density. So as I was discussing about the what are the geometrical parameter will be there, in that maybe hatching distance will be there, hatching pattern, and the powder thickness will be there. So coming to the hatching pattern, so here you can see that a different type of the profile of the hatching pattern is presented here. So in this you can see that in this way laser scanning is taking place, and after that this is moving like this. So this way our laser will scan the this layer in that pattern itself. Similarly coming to the previous layers, you can see that scanning is taking in the reverse to the or opposite to the this layer. So in that scanning is started from this way and then going to this way, and this way this will be repeating. So this way. Similarly another one is the opposite to the first one and the 90° to the previous one. So this way we can see that what is the profile pattern, so that can be varied. So similarly in the second one you can see that 2 times scanning will be taking in one spot itself. Sometimes why at one spot 2 times scanning is required? Because sufficient amount of the energy is not passing to the whatever the amount of the material is which is spread on the powder bed. So that we require certain depth and proper melting of the powder material. For that we have to pass the up to certain time period of time. So that's why in one go it may be sufficient, not sufficient. For that purpose it is repeated. Similarly in this process also repeated, one direction will be there. So you can see that all will be in one direction. So in this way, similarly you can see that hatching will be 90° to each layer. So each layer itself this type of the profile will be scanned, and then printing will be taking place. So this is the significance of the hatching pattern. Now coming to the hatching, the scanning area will be there. How scanning area will be there? Now you can see that this is our laser beam, and this is a scanning path, and then this scanning path will be moving this way, and then it can scan the entire area this way, and this way. So this is and this is the one layer thickness. 0.4 mm is the one layer thickness for the previously printed layers. So this called as the layer thickness. Similarly, hatching gap is nothing but the distance between from here to here. So here in this case 0.2 mm thickness hatching distance will be there. And this is the one profile will be there. So how printing will be taking place, and we know that we are using the Gaussian pattern. Profile will be there, so we can see that this profile will be presented here, or from that one can understand. So this is the substrate. So over that substrate powder material will be spread, and then scanning will be taking place, and then what could be the scanning speed, similarly scanning direction, so those will be there. And this is the laser powder. Now coming to the laser interaction with the powder materials. So as we know that whatever the amount of energy which the laser beam having, so only certain percentage of the beam energy which is passing to the actual heating of the powder material, but the remaining, where it is going, because the remaining we know that when the laser energy is falling on the powder material, that time some of the energy will be reflected back, some of the energy will be transmitted in the powder, so some of the energy will be go for the reflections also. So in that all energy is not going to the, so that's why some of the convection will be there, some conduction will be there, reflections will be there. So sometimes powder becomes a vapor. So in that way, now you can see that conduction is the whatever the energy is passing directly related to contact of the body. So conduction energy is transmitting in this way, and some of the energy will be reflected back in the environment itself, and some of the material becomes vaporized. So for that purpose, here the energy beam interacted with the powder materials. So now coming to the how once a powder beam is powder material is supplied with the energy, sufficient energy, after that what will happen? It will start partial melting. Once partial melting of the powder material will be taking place, after that what will happen? It may lead to the fusion of the particles. So in this, from that diagram one can understand how the fusion will be taking place, and then this is sintering will be taking place. So now coming to the once we'll discuss about the, this is all about the how the energy will be used, and then printing will be taking place. Now coming to the different profile with the one case study, in that you can say that these are the different profile of the electrode. Why different profile of the electrode? Because a person to person electrode design may be different to different. So for that purpose one can go for the one profile. Similarly, sometimes surface electrode is required, sometimes needle electrode is required. So you can see that these are the needle electrode. Similarly, this will be the surface electrode. That's why different profile of the electrode is required. So here the design of the mechanical structure of electrode using 3D printing modeling software will be required. So as we know that CAD model is required, so in CAD model we can use the any design software like CATIA, Fusion 360, similarly Creo. So SolidWorks, as per the requirement one can go for the, so once your CAD model is required, and then you can go for the printing of the whatever the layers will be there, layer upon layer building will be taking place. So here the multiple design iteration will be required, as we are handling the powder metallic material. That time one go energy beam may be not sufficient to provide that much energy, so that multiple times you have to perform. Similarly, the one can perform the coating of the printed part, because sometimes you are not using the metallic material of the powder. So in that case coating has to be performed. So that's why suitable coating material one has to be select also. So similarly, the testing of the electrode you have to perform, and characterization of the electrode you have to perform. Yes. So these are the different type of the design which is available in the, so this design we have taken the this research paper. In that you can see that these are the different version of the like electrode profile. So after that final version, this is the final version, and that was decided, and these are the different design also. So one can see that how the designing will start, and the final printing will be taken, and these are the final printed profile of the electrode will be there. So now we have to perform the suppose understanding about the coating of the electrode. So coating of the electrode, there are certain steps one has to be follow. So first that we have to clean your 3D printed part. So whatever the product or design of the electrode you have made, so that electrode has to first cleaned with the proper cleaning mechanism. Soon after that maybe surface structure of the electrode will be properly cleaned. So and after that maybe prepared silver coating. For that we have to perform the coating of the silver so for that you have to prepare the silver solutions. So by dissolving in the silver nitrate in the deionized water. So now after that one has to place the 3D printed electrode in the silver electrode solution, and it will be immersed for the maybe 5 to 10 minutes. After that maybe coating will be developed on the whatever the polymer tinted part will be there. So those will be coating will be developed. So now after that you have to remove the your coated part from the this solutions, silver solutions, and it has to be rinsed or maybe cleaned properly with the deionized water, so that no stacking of any other foreign particle will be there on the surface of the coated electrode. And after that you have to apply thin layer of the silver epoxy onto the surface of the electrode. So and then once this will be performed, after that one can go for the testing and characterization of the coated electrode. So these are the different design. In that silver coated two samples are presented here. So you can see that this is one profile, another is the another reverse side of the same electrode itself. So here under side showing the fingers. So this showing fingers of the electrode, so that this finger portion will be going inside the wound. So that this from this surface itself one can get the whatever the desired information which is required, what is the fluid contents, similarly the what is the depth, how much depth, and what is the reactance resistance of the body fluid or tissue will be there. So those information will be captured from these fingers of the electrode itself. And then similarly from this area the information will be wire will be connected with the whatever the connections will be there, device connection wire will be there from this tip itself. So there are several tests has to be conducted to characterize the performance of the 3D printed electrode. Some of the tests includes like you have to go for the impedance testing. Similarly you have to go for the signal quality testing. So similarly variability testing will be there. So similarly long term stability of the electrode is there or not. So those things will be done. After that one can go for the what is the you have to reduce the how much the different variability will be there, or noise or anything, so that it can be having the proper signal. So you will require electrode material for that. Similarly the what is the electrode shape and size, similarly the electrode surface treatment process. So these are the some variability. So for the change in the electrode impedance of the electrode will be there. So electrode placement is also one of the important factors. If it is not properly placed in the proper places, so it will not capture the proper information. Once we are not capturing the proper information from the body, what are the area where the bond is there, so in that case the proper analysis may be not taking place. If the proper analysis is not taking place, in that case what will happen, it may be lead to the proper improper information. So doctor may treat in the wrong direction itself. That's why proper getting information about those is accurate information is very essential. So then one can check for the whether electrode impedance is matching or not. So those information, so for reducing impedance of the electrode, we require careful consideration of the electrode materials, shape and size, surface treatment, placement and impedance matching. So these are the very important factor. Then what are the factors that will influence different frequencies? So current frequencies, so those detail will be discussing. So here the first BI can be performed at different frequency of the alternating current or AC current ranging from the kilohertz to megahertz. So similarly, the choice of the frequency depends upon the specific applications and the electrode property of the tissues. Similarly, the electrodes at different frequency have the shown to different like effect on the healing process. So that's why we are performing the information about the what is the healing status. So based on that only the what is the information received, doctor can start the treatment process. So BI impedance may be talking from maybe I discussed earlier 10 kilohertz to 100 kilohertz, resulting in significant faster wound healing than the other frequency. So these are the ranges. In between this range, optimal value of the analysis can be done and the faster healing process will be done. So this BI electrode method treatment may have increased blood flow to the wound side. So because of that analysis, we can know that what is the fluid content. So it will lead to the more blood flowing to the wound area, so that it may take faster process for the healing process. Similarly, what are the potential factors that can affect the accuracy and reliability of the electrode or includes wound exudate will be there. Similarly, the tissue dehydration will be there. Similarly, the tissue composition, electrode composition. So similarly, shape and size of the electrode, electrical interference will be there. Similarly, patient factors will be there. So these are the factors that will affect the whatever the electrode measurement detailing will be there. So those will affected. So similarly, the mechanical performance of the BI electrode can be performed like what is the adhesion capability. Similarly, what is the flexibility, how much flexibility of the electrode is there, they are rigid or flexible. Those can be done proper testing characterization. Similarly, durability of the electrode, similarly shape and size of the electrode will be there. So those factor one has to be knowing about, and from this value the what is the mechanical properties of the electrode will be there. Those will be can be predicted here. Similarly, whether the biocompatibility there or not, that also can be done. So similarly, the recording performance of the BI electrode in wound healing types depends upon the there are various factors. So the performance of the BI electrode in terms of the recordings may vary based on their design, materials and applications. So similarly, the surface electrode have shown that to provide more accurate and reliable measurement. There, as I was discussing about the different type of the electrode, so maybe surface electrode can give the more accurate information, reliable information than the other type of the electrode. Similarly, the needle type of the electrode will provide more precise measurement of the electrical properties, particularly at the more deeper levels. So more at the more deeper level, this needle electrode will be better than the other type of the surface electrode. Similarly, adhesive electrode have shown their good contact with the skin and can give the useful in the area where the other electrode may not be adhere properly, such as the bony area or joint. So those area this adhesive electrode will be more suitable and it will give more accurate information than the other type of the electrode. So similarly, the what are the like noise performance of the BI electrode in the wind wheeling will be there discussing. So these are the key factors that will affect the noise performance of the BI electrode in the wind wheeling process. That includes electrical materials, electrode design. Similarly, cable shielding will be there because it is electrode will be connected with the different cables. So proper shielding of the cable is also very important. Similarly, the what is the patient motion will be there, movement will be there, that has to be stopped. So by any means. Similarly, the how the signal is